Hello everyone, my name is Mohammed and the design pattern that I chose to present is bridge design pattern. So let's start. This works. Okay. So what is bridge pattern? So bridge pattern is a structural design pattern that lets you split a large class or a set of closely related classes into two separate hierarchies, which are implementation and abstraction. And you can implement each of these hierarchies independently and without affecting the other one. So the question that comes up is that when do we use this designing pattern to help us to improve our code or our project? Well, developers usually use this pattern when they want a runtime binding of the implementation, or they have a proliferation of classes resulting from a coupled interface and numerous implementations, or they want to share an implementation among multiple objects, and or if they need to map orthogonal class hierarchies. So definitely, bridge pattern has some advantages and some disadvantages. Let's start with the advantages. So the first thing is loosely coupled code, which means as bridge pattern decouple abstraction from its implementation, the implementation can be changed without affecting the client code. And the client code does not need to be compiled when the implementation changes. Also, it increases the code maintainability, reusability, and reduce code duplication. It creates platform independent classes and applications. Helps to promote the open closed principle. New abstractions and implementations can be developed independently. The decoupling abstraction from implementation, which means bridge pattern can be used to avoid the binding between abstraction and implementation and to select the implementation at runtime. And also it improved extensibility, which means that abstraction and implementation hierarchies can be extended independently. And one other thing that bridge pattern does is that it hides details from client. And some of the disadvantages are bridge pattern implementation increases code complexity, interfaces with only single implementation, and multiple indirection, which means a level of indirection is introduced as the request is passed from the abstraction to the actual implementer. Okay, so I found a really easy and understandable class diagram for bridge pattern. And as you can see in the class, we need like a bridge pattern design needs to have like at least four classes, which are abstraction, redefined abstraction, implementer, and concrete implementer, which we are going to go in depth of each one. So abstraction is core of the bridge design pattern and defines the crux, and also it contains a reference to the implementer. Redefined abstraction extends the abstraction, takes the finer details one level below, and hides the finer elements from implementers. Implementer. It defines the interface for implementation classes. This interface does not need to correspond directly to the abstraction interface and can be very different. Abstraction provides an implementation in terms of operations provided by the implementer interface. And the last class, which is concrete implementer, implements the above implementer basically by providing the concrete implementation. So since now we know what bridge pattern is and how it works, let's go through a scenario. Okay, so the scenario, so let's start with the right picture. So we have a class called shade, which has subclasses of circle and square. And now we want to extend this class hierarchy to incorporate colors as well. So since we have two other subclasses, each of these classes either can be like blue or red. So in this case, we need to create four other subclasses for each color in each shape. So for example, for circle, we need to have like a red circle and blue circle, and for square, we need to like the same thing, red square and blue square. So adding a new shape types and colors to the hierarchy will grow it exponentially. Which means that if we want to like add any details to this class, we need to extend this like hierarchy, and it goes like it grows really fast. So for example, if you want to add a triangle shape, we need to introduce two subclasses, one for each color, which is red and blue. And after that, adding a new color would require creating three subclasses, one for each shape type. And so to solve this problem, we can use breach pattern. So the breach pattern attempts to solve this problem by switching from inheritance to the object composition. What this means is that you extract one of the dimensions into separate class hierarchies so that the original classes will reference an object of the new hierarchy instead of having all of its state and behaviors within one class. And that's how we solve that, growing uh, class issue that we had with the method that first I explained with using bridge pattern. So I implemented it like an example similar to the scenario that we went through. So in this scenario, we have a class of painters, which has two subclasses of painter 1 and painter 2. And there is one class which is shape that they can draw, like each painter can draw. And that one has four subclasses, which are tree, house, and car, and portrait. Uh, so uh, so if we want to do this without breach pattern, if we want to implement this example without breach pattern, we will end up with multiple subclasses for each drawing and painter. And also again the same issue with the painting, the color and the shape example that we went through. It grows like the class hierarchy grows really fast, and we don't want that. So let's go through the implementation. So for this project, instead of using classes, I use a structure. Basically, both of them are the same thing, but the structure makes the code more clean and in my opinion, it doesn't make it super, crowded. So I just use a structure, but both of them are the same thing. So what I did, I created a structure of painter, which has an abstract function called painting. Then I created two subclasses, which are Painter 1 and Painter 2, and which both of them inherits from Painter class, and they just override the painting function inside the Painter class, and they just print out a message which shows which painter is drawing an object or a shape. Then I worked on the shape structure, which has an abstract function called draw. And also we create a object of painter class called painter num. And for this the structure constructor of a shape structure, we are passing object of painter to the shape constructor, and also we pass that one to the painter num as well. So basically this is the part that the shape class doesn't need to be worried about which painter is gonna paint the object. Then I worked on the subclasses for shape. The first one was tree, it inherits from shape class and override the draw function. So basically what it does, first we are passing an object of painter to the tree constructor and to the shape as well, and then we are calling the painting method of painter, the object that we created, painter num, and then we're just going to add like a shape to it. And for the house and car and portrait, I did the same thing. Like they were like similar as a tree structure that we have. And then after that, in the main, I created two objects of one painter one and one painter two, and called them Ali and Mo. And then I passed them to portrait and tree classes, and then called the draw function. And this is the result of the run. So the first one was painter one is drawing portrait, and the painter two is drawing a tree, which is the right result. And these are the references that I used for this presentation to find the information. And thank you so much for listening. Bye.